Hey, what's up YouTube? Here we are. So back again, day 24. If you're just joining us, we're doing mechanical engineering theory for HVAC optimized start mathematics. So we're kind of looking at these optimal start models defined in research, and we're just putting it together in Python code, trying to make sense of the research papers. So in the previous videos on some primitive building automation system, we can feed in some data to these models, and then they always output minutes as our target variable to condition the zone for building occupants. All right, so this is our AI generated coursework, and then the PNNL white paper is in here. So here we are, we're on day 24. So day 23, yesterday's video, they gave us some data for Model 3 that we're up against. And then we were kind of looking at this this weather factor. So if we do Python math lesson, we are kind of calculating our predicted minutes from here. So now we're kind of continuing off of that, I think. Oh no, actually, we're kind of getting into some of the linear algebra. Maybe computer science, they would call it more like matrix algebra, but for engineers, there would be like a whole course on linear algebra for engineers that you would take as like a college semester. So it's been 20 years since I've touched this stuff, so I'm just kind of looking at it at like a really high level and like not going into it super deep. So just using some math libraries. I honestly can't even remember my college coursework in this, but it's been a little while. So let's just look at it from like a really high level. And I asked the AI when it generated the lesson plans to make it really high level, easy enough that like building automation technicians could even understand it, which I have been for a long time. That was my role for 10 years, where you're not really actively using this stuff. You're more like an IT guy for operations technology, or just setting up technology really fast, and you never have the time to actually look at the math running in these building automation systems. You're just deploying technology. So, okay, here we are. Let's get into it. Day 24, the multiple regression concept. Goal is understand fitting a plane against a line. So unlike simple regression, which we did before on like model 1, the quadratic regression, that was just fitting a line. Multiple regression fits a plane in higher dimensional space. Each data point has two inputs. Delta temperature, which is the zone temperature minus the occupied zone temp set point. So if the building drifts overnight, getting hot or cold, it's this delta temperature, and also the delta temperature times the weather factor and another input and one input t. The goal is to find the coefficients that minimize the sum of squared errors across all points. You can solve this using matrix operations or libraries like scikit-learn. This lesson introduces the concept without delving into full linear algebra. Understand this concept allows you to build more accurate and efficient optimal start models. Okay, so maybe we can just copy this. So there's this is like a math library in Python. It's called NumPy. Pretty famous in the Python world. It's been around forever, but a lot of like the machine learning libraries and really fancy analyst libraries, they'll use NumPy under the hood So it makes math operators really fast. Like I think it's all written in C or C++. So like I've seen YouTube videos where people make like really crazy math calculations, or they'll do tutorials on creating like machine learning algorithms from scratch, and then they compare the difference using just raw Python, pure Python for math, versus using NumPy, which uses compiled C++, I think, and it runs really fast. So it's NumPy has a lot of cool math stuff. Okay, so I might just actually comment our lesson from yesterday out. So if I run this, what does this do? Oh yeah, I wanted to say, like, if you're kind of new getting set up on Python, you can install packages with a package manager called pip. So I'll do python-m pip install NumPy, and I have it installed already. So, but if it's not installed, it'll run through the. You can also upgrade to the -- upgrade. And it looks like there's an update. So now it's updating NumPy. Pip is the package manager for Python. One thing that I kind of wanted to do was there's another Python package called scikit-learn. Scikit-learn. So I think it's scikit-learn. So scikit-learn it's like a machine learning library. Looks like that failed. So I think I just have something wrong here, but you can even plop this in Google these days. I'm on Windows, PowerShell. For some reason, this runs like a lot faster than trying to use ChatGPT through the browser. So yeah, I guess I had the install command wrong. So, and it's already satisfied. Oh, actually, it did actually install scikit-learn. So this might be fun to play around with even later on. Maybe we can make some machine learning models with scikit-learn. If you can see under the hood, it's also using SciPy, which is another science toolkit for Python. Pretty popular with NumPy. Alright, so let's get back into it. If we go, I'm just looking at some notes here on a different monitor. Okay, so this is just setting matrices out. So this is like I guess like an array. I think you can think of it like as an array of data matrix. So like this will just compute like the x, and the target variable is y. So this will run basically it's crunching a lot of the matrix math behind the scenes using this NumPy column stack command, and then it'll basically it'll pump out our coefficients for our model 3 defined by PNNL, which is alpha A, alpha B, alpha D. So let's I'd be kind of curious just to print like what comes out of the NumPy directly. So let's just see what this looks like. Just adding another print statement here. Run our correct command. So it looks like when you get data returned from NumPy here, it's just returning like an array back to you in this format. It's like a list, they call it in Python. So this is actually returning our data, and then this is actually just unpacking that. So it's this is just an array of data right here, and it's actually returning this. So it's kind of doing all of this hard matrix algebra for us. Yeah, so how did I want to explain this? So so we've been talking a lot in this course over the couple weeks that like we're always looking at a temperature delta, very important, and then usually like our target variable is always minutes. So this would be minutes here that we've recorded. So some of the other videos, there's some computer science patterns that capture this, like when the optimal start algorithm runs, it records the temperature at which the let's say it's 5 o'clock in the morning, the building's hot or cold, and it starts up at 6, and there's that's our temperature delta is our zone temp compared to the occupied zone temp set point. And then this for this particular model, it's this weather factor, which we actually played around here. Maybe this would be kind of fun to use this. So we did calculate weather factor here. So I'm just going to delete this out. So weather factor. Actually, I think this might change for every day. So like maybe this is a bad example to because I was curious to use weather factor here, which is this number right here. So you can see like this little math operator is the value 8 times weather factor right here. So this would change every day. So like the time that the optimal start algorithm runs, like we're recording the delta temperature and then also calculating its weather factor, and then whatever the outside air temperature is at that given time, that would that's why this weather factor would be kind of slightly different number, even though this is all fake data right here. Yeah, so maybe that's bad. We can just kind of run this, kind of fun to play around with. So it's these are our tuning reps. So this is our basically our math equation that we would use to output minutes, I think. See what our lesson plan tells for us to do. Explain why we add a column of ones to the matrix design. Ooh, I do not know that. Generate your own data set and fit this using the code above. Why might fitting model 3 be difficult in a BAS controller without matrix support? Well, that's yeah, that's I'm talking a little bit about this. Like the Tritium program object doesn't support this out of the box, so it's just a lot more complicated matrix algebra code that you would have to do by hand. That, you know, it's just more prone to make more mistakes. Okay, so what should we do? So generate your own data set. So whatever, we can just play with these numbers. So here it's going to add a value of 2. All right, you know, play with this, and then we could even change our minutes maybe. There's our another fake synthetic data set. So now we have different coefficients. So I guess I can't really remember why we add a column of ones to the design matrix. I also want to say that it's because like this is are they the same dimension? So they have like how this is like 3 values here. Like to do this, like you would also need 3 values here. So I don't think I'm explaining this right. So let's ask AI. Maybe I'll just put this over here, and then maybe I'll just cheat a little bit. I'm just gonna say copy you into here, and I'm just gonna say on this question, is it because the matrix needs to be the same shape, 1 dimension, etc. Please help me understand correct terminology. Okay. It's been a while and I can't really remember. I kind of know like what they're doing from a high level, but it's like I said, I've been taking this stuff in 20 years, so the correct terminology is it's been a little while. So I might just kind of peek ahead at day 25 because I think these might be really similar. See if we could do 2 of these at once. Suppose we could just save this for tomorrow. So like these like matrices, like they need to be the same size in order to create to do math against. So I think that's what. Great question. Very close. Why do we need to add a column of ones to the design matrix? The short answer is we add the column of 1 so that the regression model can learn a constant offset term, the intercept. Without it, the model will be forced to pass through origin, which is usually wrong in the real world. The regression model form assumes the model T, here's our alpha parameters. Okay, so it's x1, x2. The last term, alpha D, is the intercept, sometimes called the bias. X1 is our delta temperature, X2 is our delta temperature times the weather factor, D is the constant form, so even on easy days, the system always needs 10 minutes of startup overhead. So linear regression solving T equals X times alpha. To include a constant term, one of the columns X must always be 1. Then the parameter vector is alpha. Okay, I think that kind of makes sense. The ones column picks up the intercept. The solver can learn that baseline offset. It is not done to fix shape or matrix either. Without it, the columns of ones, the shapes already work fine. You've already been solving this in a restricted model. What forces the prediction plane must pass through the origin, meaning that if delta temperature equals 0, weather factor equals 0, and predictum time must be 0. In real HVAC systems, don't behave like that. We talked about that before, that there is like lag. So I think that's what they're referring to. Here's a clean phrasing you can drop in directly. We add the column of ones to the regression, can learn an intercept term in matrix form. This allows the solver to include a constant offset in the prediction model instead of forcing the regression plane to pass through the origin. Physically, this represents the baseline startup time that HVAC systems always need, even when delta T appears small. Okay, I guess I'll buy that. Another thing I was kind of curious to do is demonstrate the same code base that we did with NumPy. So I just wanted to see where to go. Let's see, so we had the same code base through some previous chats. Let's see, so I'm going to actually put this back because we modified these values to here. So this is the NumPy version. And then I could just do like a print, some kind of spacer right here. I'm just doing this to make it look like, add some spacing. So I just wanted to see what this would be like from doing it this way. So, okay, so we can do the same thing as we did in pure NumPy, except I think what it might look a little bit cleaner and easier is using scikit-learn. So this is our same, actually these are, we could just use our same array values here. Yeah, okay, so see how we have this NumPy array here, and which is the same thing here. Same thing with here, our minutes, our target variable. Okay, so then this is getting into a little bit of scikit-learn code base, so I just want to copy this and put it here. So since we defined X and Y already, we can see what it looks like when we run scikit-learn and NumPy next to each other. So it's interesting that the lag that it took to compute that. I just want to do that again. My computer must be running a little bit slower, but for whatever reason, it's maybe it's a little bit more fancy math, but I think this stuff is really easy for the computer to do with just a teeny little data set, but there's a little bit of noticeable lag. So you can see we get basically the same numbers. We could even do, whoops. This is just for demonstration purposes, so we called it up here alpha A, copying you down here for alpha B, alpha D. Run this again. Going to get rid of this too. So all this will do is just, pure NumPy linear algebra library versus using scikit-learn, and it's just like a little bit easier to look at. And you can see we get the same results. So different under the hood. We're just crunching numbers with this package instead of pure NumPy here. So I think moving forward, if we do any more of this stuff, I would prefer to look at this. It's much more easier, more of like a modern machine learning library too. So that is it. That is all I have for today. Hope you guys are getting something out of this. I'm learning quite a bit, and it's kind of fun to implement this stuff in the field too. So yeah, I think I might even try to, it would be fun to make some 3D plots too of this, just to see what they look like. So yeah, I hope you're getting something out of this, and I'll see you guys tomorrow for day 25.